next one, we actually are just going to summarize what you know. This is just a summary of every way of proving these. So you have on here 1, 2, 3, 4, 5, 6 ways of showing that parallelograms are going to happen. Now, each one of these you could literally say, this is just the quick rendition of it, but you start with going, oh, if a quadrilateral has these properties, then it is a parallelogram. So let's look at the first one. And we're going to be marking up diagrams and stuff to help us. So you're going to probably see me redrawing this just so it's easier for us to mark up because I'm using pen. Let's look at the first one. It says the angle SPT right here. So this whole angle right here is congruent to angle SMT. So this one right here. Well, does that fulfill any of these up above? Does it gives me a pair, one pair of opposite angles congruent, but does it show both pairs? No. So let's state whether it works. So no needs one other pair of opposite angles. Excellent. So we want to make sure that we have those. Now let's look at the next one. We're going to mark it up. Let's look at the next one. They say angle SPX is congruent to angle TMX. So SPX, so I'm going to use a different one here, is congruent to angle TMX. Okay, so those two are congruent. Now guys, I want you to look at this. Are those alternate interior angles? Yes. So does that make parallel lines? Look at the next one. TPX is congruent to angle SMX. Oh look, alternate interior angles. That makes these lines parallel. Oh, do I have two pairs of parallel sides? Yeah. So my reason for this would be yes, they are parallel. It is sufficient because we have both pairs of opposite sides parallel. Okay, let's do the next one. I'm actually going to draw it in here. Just quick drawing of the quadrilateral. So we have SPTM, and I'm only going to mark what they have here. I'm not going to draw the diagonals. They tell me that SM is congruent to PT. They told me that SP is congruent to MT. So I go up here and I'm like, oh look, I have pairs of congruent sides. So I have anything up here that talks about that. Yeah, if both pairs of opposite sides are congruent. Are both pairs of opposite sides congruent? Yes. So they're gonna, is that enough information? Yes. So we go yes, and the reason why, remember, because both pairs of opposite sides are congruent. Now guys, remember, we're trying to show sufficient information here. Sufficient. All right, let's look at another one. I'm going to redraw the diagram again because we don't have enough room with the pen. So we have SMTP. I'm going to put my X in here. Now look what they have here. They tell me that SX is congruent to XT, and they tell me SM is congruent to PT. Now is that anything? I got one pair of opposite sides congruent and I got one pair of diagonals being congruent. Does that give me enough information to show that's a parallelogram? No. Not enough info. I need to show that these two are either congruent to each other, or I need to show another pair of opposite sides congruent. It doesn't work otherwise. All right, let's do another one. I'm going to redraw the diagram again. I'm not sure why I picked the red, but we'll go with it. We'll go TP. I'm going to redraw this. Here's X. Now I'm going to mark it in. Segment PX is congruent to MX. We have segment SX is congruent to segment TX. Those are the diagonals. Do I have anything that talks about the diagonals up above? Yeah, the diagonals bisect each other. Do the diagonals bisect each other? Yes. So do I have a parallelogram? Yep, you got it. Yes, because the diagonals bisect each other. You're thinking the Y's. Now let's do another one here, diagram. Have SMTP. We're going to do our diagonals and get an X. SP is congruent to MT, and we know SP is parallel to MT. Now, again, I have a pair of opposite sides, one pair that is marked congruent, and it's marked parallel. Do I have anything that talks about that? Yep, number 2 here. One pair of opposite sides are parallel congruent. Does that make a parallelogram? Yes. And so we'll say that. Yes, because one pair of opposite sides is both parallel and congruent. I fulfilled that definition's hypothesis, so now I know it works. Right now, let's do a couple quick examples of applying those. Now they say, find the values of x and y for which the figure must be a parallelogram. Well, if I want this figure to be a parallelogram, what do I need to know about the opposite sides? They're parallel and they're congruent. So I'm going to assume that my opposite pairs of sides are congruent. Now I want to solve for y, but I don't want to have to do a system of equations. So guess what I'm going to solve for first? I'm going to solve for x first. So I'm going to go over here and get 4x plus 20 because equals x plus 26. So I'm going to go ahead and figure this out. I'm going to subtract x from both sides. I get 3x plus 20 is equal to 26. I'm going to subtract 20 from both sides. It's 6. Divide by 3. X is equal to 2. X is equal to 2. Now, when you do that, the cool thing is now I can go ahead and solve for y because I can do a plug and chug equation. I know those two are equal. So I'm going to go 7y is equal to 6 times 2 plus 9. So when I do that, I get 7y is equal to 12 plus 9, which is 21, because remember all I did was plug it in here to get this length, okay? Divide by 7, y is equal to 3. So x equals 2 and y equals 3. Now I know I have enough information to make it a parallelogram. Now let's do the same type of idea over here on number 9. I skipped 8 so we had room to work, so just understand that's why the numbers changed. So you can call it 8, 9, whatever you want. Now, in order to have a parallelogram, I want opposite angles congruent and I want consecutive angles to be supplementary. Now, notice if I did opposite angles, I'm going to get a variable again, and we want to avoid that. So instead, let's do consecutive angles, ones right after each other. Those I can show being supplementary real quickly. So I can go 12y plus 8 plus 5y plus 2 is equal to 180. So I get 17y plus 10 equals 180. Subtract 10 from both sides. Divide both sides by 17. Y is equal to 10. Now I want to be able to use that to help me get x. Well, I'm going to use the fact that I want these two to be congruent to each other because opposite pairs of angles are congruent. So I'm going to plug in 10 up here and get 12 times 10 plus 8, which gives me 128. So I know that 2x is equal to 128. I'm going to divide it by 2. And what am I going to get? X is equal to 64. X is equal to 64. Now, I might have shown a different way on my notes if I've given you a copy of the notes and you're reviewing this, but think about there's a lot more ways. You could also use the fact that these two add up to 180, so you can go 2x plus, and if you plug in the 10, you get 52, equals 180. So there's more than one way. So you could have gone 2x, this would have been 52, plus 52 equals 180, and you're going to get exactly the same answer. So that's the cool part about math. There's sometimes lots of times more than one way of proving it.